In triangle ABC, the size of angle ABC is 30 degrees, the side length AB is 3x plus 2, and the side length BC is 7x minus 4. Write an expression in terms of x for the area of the triangle. So area is half AB sine C, so that's going to be a half 3x plus 2, 7x take 4 times the sine of 30 degrees. We know the sine of 30 degrees is a half, so we could write this as a quarter 3x plus 2, 7x take 4. In triangle DEF, the size of angle DEF is 60, the side length DE is 2x plus 1, and the side length EF is 3x minus 1. Write an expression in terms of x for the side length, for the side DF. So, DF is, let's use the cosine rule, and since we want DF we'll need to square root the whole thing. So that's 2x plus 1 all squared, add 3x take away 1 all squared, take away twice 2x plus 1, 3x take 1, times the cosine of 60 degrees, which is a half, and so that half cancels with the 2 in front there. So we'll just end up with that. Given that the numerical value of the area of the triangle ABC is 5 more, and note that is 5 more, not 5 times more, than the numerical value of the perimeter of the triangle DEF, when the value of x is the same for both triangles, determine the value of x. So the area, that's a quarter 3x plus 2, 7x minus 4, is going to be 5 add the perimeter of this triangle. The perimeter of this triangle is 2x plus 1 plus 3x minus 1, add the square root of all of that stuff from down there. So we want the value of x. Let's solve. So let's just clear everything else. So action, advanced, solve. And what do we have? We've got 1/4 of 3x plus 2, 7x take away 4 is equal to 5 add 2x plus 1 plus 3x minus 1, add the square root of 2x plus 1 all squared, add 3x minus 1 all squared, take away 2x plus 1, 3x minus 1, and then we need to be out of that, and close the bracket, and execute. And well, it's a length, it can't be negative, so it must be the x equals 2. From the top of a vertical cliff, a boat is seen out to sea. The angle of depression of the boat from the top of the cliff is 14 degrees. After the boat has moved a further 600 meters directly away from the cliff, this angle has decreased to 9.5 degrees. Determine the height of the cliff to the nearest meter. So a good diagram is needed here. This is the cliff, and here is the sea. and this is the horizontal here. The original position is, say, here, and this angle is 14 degrees. Of course, this one's a right angle. Now, a bit later on, it's moved out to here, and this is 600 meters, and this angle here is 9.5 degrees, meaning the angle here would be 4.5 degrees. Now, just using alternate angles, this angle here must be 14 degrees, meaning this angle here is 166 degrees. And that's going to enable us to work out this length here. So I'll call that x. So, it's worth noting, of course, that this angle here is 9.5 degrees, using alternate angles in the other triangle. So, using the sine rule, we have x over sine 166 is equal to 600 over sine 4.5. So we can find x from that. So x is going to be 600 times sine of 166 over the sine of 4.5, and I'm still in degrees, so that's all okay. And so that gives me 1850.04, and so on. Now we want h here, so sine of 9.5 degrees is going to be the opposite, which is h, divided by the hypotenuse, which is x. So h is going to be x times sine 9.5 degrees. So x is my last answer, so we'll just multiply that by sine 9.5, and that gives me 305.3 ... and we want it to the nearest meter, so that's 305 meters, correct, to the nearest meter.